What is up, car and craft fans? Welcome back to part 2 on making a custom Arduino which can power a bunch of lights inside the car. So what we're going to do here in part 2 is create an iteration to what we did last time, building on the circuit and building on the programming to allow us to add a new option where we can set the color of the light based on an application, a mobile app, that we're going to build and have communicate with the Arduino via Bluetooth. Why would you want to do this? Well, in my case, I have a 350Z and I have underglow. And because I have underglow, I often want to make the light on the back of my car match the color of my underglow. It's a stupid little thing and not many people are going to have this requirement, but you might be using this to create internal lights for your car or anything else that you wanted. You want to be able to get in there and change the settings. Yes, we're going to be looking specifically at changing a color, but you can use the same process to unlock the ability to change lots of things if you wanted to have animations or different patterns for your indicators or whatever it might be. This part of the process is going to be technically semi-intense, but I'll break it down like I did in the previous one, and hopefully everything that we're doing is going to make sense. So you'll be able to do this even if you've never ever done any of this kind of stuff before. And actually making a mobile app using some tools online that are available for free, pretty easy. First things first, let's just remind ourselves where we're at with the existing circuit. So during part 1 of this build, we created this circuit, and at the very end I'd put in this voltage regulator and optocoupler. I have removed those, so we're back in prototyping mode, and we've gone back to the point where we had the 2 buttons attached to the lights. When we plug it in, the default red comes on, then we can press one of the buttons to go into brake mode where we get full red lights, and the other one to go into reverse mode that goes white. I realize my camera makes this look blue, but it is actually white. So what we're going to do to start with is expand the board by adding one extra button input to simulate the input when I switch my underglow on and that circuit being live. So much like we did last time, we're just going to add another one of these momentary 4-pin buttons. Oh, and I don't drop it. Yeah, so let's space them evenly just for aesthetics. Yeah. Then I'm going to need to wire in the ground terminal. There you go. Oh, and we should have actually, safety first, we'll always unplug before we start adding more things into a circuit. And then we need to add another wire here to connect this button into one of the terminals in the Arduino. We've currently used 12 and 11, so we'll put this one up here with them in 10. So that keeps the 3 buttons together. This is where we left our Arduino sketch. I have done a couple of small changes to it since we left it in the last version, and that's just because I wanted to add some more notes and things on it, because if you go onto the previous video, you can download this sketch file, much like in the description of this video, you can download this new updated sketch file that we'll get to at the end of here. I just wanted to add some more notes in there. Also, there was one issue in the previous one that I didn't pick up on until after that I'd finished editing the video, and it's this little thing here. If you recall, what we did was make the current state and the save state both D when the application initialized. The problem that meant, starting them both in daylight running mode, is the setup happened and went all the way through and nothing happened. And then we went into the loop, and as soon as we get if current state is equal to save state here, they're the same. So it didn't set DRL mode when you first plug in the Arduino. It would only do it after you press one of the buttons, because then the state had changed, so the 2 things are out of sync. Because the 2 values were the same initially, it didn't set daylight running mode when we first plugged it in. So what I had to do was just come up here and change the save state to an empty string or an empty byte. You can't just have nothing. It needs to be a single character. So just an empty byte, which means now when it loads, it actually comes in and it compares them and it goes, oh, actually the current state should be D, and it compares them and it sets DRL correctly. Also, everything is a little blurry, so I forgot to go into geek mode. Dun, dun. There we go, perfect. So that with those changes, this is what the sketch was like. And we've just added a new button into slot number 10. So we need to add the controls for that. So as I was explaining last time, we can just add pin for, actually just shorthand it to glow, is pin 10. And that's the pin for my underglow. And just because I'm a little bit anal, let's put them in order of the pin numbers. The LED attributes I'm going to change. There is potentially going to be a new state, which is the underglow state. Oh, there's not potentially going to be one. There is going to be one. That's just a note, so that actually putting that there doesn't do anything. We've got a new pin, so let's put the pin here. Pin glow is an input pull-up again because it's using that internal input resistor. And we have to sense when the underglow is happening. So brake light is highest priority, reverse is second priority, otherwise go into else if the state of glow is equal to low, then current state equals G. G for glow. Did I just put G for glow or did I use? No. Let's just keep it consistent and keep it glow throughout. Also, I need to add the byte here. So this will set the high-low value of the pin for the underglow. So state glow is pin glow. So then we need to have one more case here for this. So brake, reverse, case G, and that would be set underglow or set glow. Brake. And the final thing then is to set have a function here. So let's copy the reverse function and set the glow state. So glow, big capitals. So what do I want the default to be? So we're going to just make sure the button works to start with. So make all lights underglow. And what we're going to do is set it to normal brightness, 0 normal brightness, which is RGB. So red, normal brightness, no blue, normal brightness, green. Sorry, blue. So it's part red, part blue, which is going to give us a purple light. So we can check that that all works. I'm going to verify that. Oh, set glow. Oh yes, I haven't changed the the function name there. Set glow. That compiles, all groovy. Plug it in. Upload. Let it finish flashing, do its thing. We should have now purple. Yeah. So we've got brake light, no, underglow, reverse light, brake light, underglow. So the underglow will be something that is just turned on. Basically, in the cubby of my 350Z, I've got this hidden little panel, and I can have I've got some big toggle switches, and when I flick them up, it turns the underglow on and off. It's because they go into a constant power source. So I can basically take my keys and everything out of the car, lock it up, but still have the underglow on. So when I'm leaving it at shows, it can sit there with the glow on. Yeah, and also you can see here glow is glowing when we press that button in the serial. So we know everything is running great here. But I don't want it just to be purple. We're going to want to be able to set that color to mimic the underglow color with whatever one we want. There's two things to do here. A, build an app that tells it what color to do, but also the Arduino is going to need to remember what color we've stored and save it. Because when I turn my car off and then turn it back on again, the underglow remembers what color it was. I don't have to go back into my GlowKit app. So I use GlowKit, underglow, and interior lights. I don't have to go back into the app and reset it to whatever color it might be. It remembers it, it stores it in memory. So we need to do the same thing, because I don't want every time I turn it on to have to go into my phone and reset the thing. So we're going to create a memory state to save the red, the green, and the blue values into, and then extract them. We're going to do that in the program here. We need to add a new package. So we've currently got the one included for the Adafruit. So we're going to need to include another one, which we have probably linked, EEPROM. So it's a default one that's part of one of the default Arduino libraries. And EEPROM is the internal memory, the little memory chip that is inside an Arduino. It stands for electrically erasable programmable read-only memory. And it is basically a little rewritable storage chip on the Arduino. I believe it's that thing, that part of the chip, and it can store memory even when power is disconnected to it. So we're going to create a way of, like I say, using that to store the red, the green, and the blue values. There is a point to remember here, and it's a limitation with EEPROM, and that's a slot, a memory slot, can only be written to 100,000 times. So let's say you're using slot 5 as just an arbitrary number. You can write to slot 5 100,000 times, at which point it will stop working. Now 100,000 times is a lot of times. If we do 100,000 divided by 365, we could change it once a day for 273 years. So the chances of us actually getting anywhere near setting 100,000 times is pretty slim, except for the fact that loop in our Arduino program could be a problem, because it sets every few milliseconds. So if we were to accidentally have a write state inside the loop without a break that stops it from writing, it could easily write tens of thousands of times to the right. So just something to be cautious of whilst we're doing this. So we've included this EEPROM. That means we now have the package that allows us to use internal memory state. There are a couple of things we're going to want to do, and we're going to start by creating some global variables up here. So you notice these are being defined before setup. And the reason you define them before setup is that means you can use them in setup, you can use them in loop, you can use them inside one of the breaks, you can use them anywhere in the application. If you were to define these variables here, and like say state glow is defined here in loop, it's not available in any of the other void functions. They're contained within that function. So by having them at the top here, they become global variables, the same way as byte and current state are here in our state management. So we're going to create initially 3 variables, which are integers, because we're hoping that the thing that is saved in those slots is going to be a number between 0 and 255, because our number limits go from 0 to 255. So it's going to be an integer, which holds a number value. I believe it's up to 8 bytes, but I might be wrong on that. Don't quote me. So pretty big number, but you know, we are only using up to 3 digits. And we're going to do memory 0 memory 1 and memory 2. By doing it like this is just a shorthand for doing it like this, one line at a time. It's just a little bit of a better practice when you're doing lots of things like that. So now that we've just created these global variables, and we'll just show what they are. So this first one is memory slot 0 that we're going to store red in. And then memory slot 1, memory slot 2 that we're going to store in green, and we're going to store in blue. So there's two things we're going to want to do with this. One is we're going to need to be able to listen to the app that is sending the colors through, check that the thing sent is a valid color, and if so, store it in memory and update the lights. The second thing is when the Arduino starts for the first time and it hears the mobile app talk to it, it wants to be able to take the values that it has saved and send them to the app in order for the app to go, okay, currently it is purple, and show what the color currently is on the app. So it's like loading the default state when the app opens for the first time. So where we go from here is after we've set up the NeoPixel, we've got these variables, memory 1, 0, 1, and 2, but there's nothing in them at the moment. So we need to take the value stored and pop it into those 0, 1, and 2. And you'll see why we've done 0, 1, and 2 and not RGB in a moment. So we're going to do memory 0, which is the first variable, is equal to, and then the code for retrieving the data from a slot is EEPROM, as we said, electronically erasable programmable read-only memory. Obviously rolls off the tongue. .read, and then the slot number. So that's reading the value of slot 1. So read memory slot, well, not slot 1, slot 0. And then we're going to do that 3 times. So memory 0, memory 1, memory 2 is going to read 0, 1, and 2. Groovy. So now, when the application loads for the first time, whatever is in memory slot 0 will be put into memory 0, ready to be sent on. But what if there's been an error? What if the code has accidentally saved something in there that we don't want? What we need to do is verify that this is a thing that we want to actually work with. And if not, set it to a default value. So instead of just having memory 0, memory 1, memory 2, we'll add a couple more to the list here and make memory R, memory G, and memory B. So now we've got these 3 extra ones, red, green, and blue. And what we're going to do is check if this is a valid color number, and if so, set it to the value of red, and if not, set the value of stored red to something default. So it's basically getting rid of that problematic set. So how we're going to do that is just by checking if the value of it is in between a certain range. So for a color like this, we want to know if memory 0 is greater than or equal to 0, and if memory 0 is less than or equal to 255, and I'm going to do this on the next row. So we're going to just do all 3 at the same time here. 1, 2, 1, 2. We don't need this and then we just need to put all of this in one set of brackets, which will just and it's all one thing that's all tested at the same time. So what we're checking is the value in memory 0 between 0 and 255? And is the value in memory 1 between 0 and 255? And is the value in memory 2 between 2 and 255? What that's going to do is verify all 3 of the memory slots at the same time. We could have done them individually, but if one's failed, any one of the 3 has failed, then we'll just reset all 3 of the memory values to a default, which will be just like a DRL default mode. So what we want to do is, if those things are correct, then memory read is equal to memory 0. So we've gone, okay, we've verified what's in slot 0, and we're going to store it in red. Same, memory green is equal to memory 1, and memory blue is equal to memory 2. But if any of those 3 conditions fail, or 6 conditions testing the 3, then we want to set this to something else. We want to set it to default mode, which we know to be 0, 0, and normal brightness. So it's going to open up the application, see what's in those slots, test if it's a number. If so, set it to those things. If not, set it to something else. So here, if we do a serial.println, we can just see what it's currently doing. So, because at the moment, nothing's ever been saved into those memory slots. Actually, something might have been saved into these memory slots because I've had this application working. So there's a chance there's something in those slots. So let's just see what's in them at the moment. So we've got, we're going to check memory read. Line memory read, G and B. So we'll take a look what's in there. Verify it, plug in and upload. So there we go, it's uploaded. And you see there are values stored in there already. So when I have been building a previous version of this app, I've been playing around with numbers. So those 3 numbers are already stored in there. But as we can see, what it's done is it's verified that they are numbers and has stored them into memory R, G, and B. If they hadn't been valid numbers, we would have got 10, 0, 0 as these 3 numbers, but they are valid, so we're all good. With that part of the application running properly, it's time to get onto the next bit, which is installing Bluetooth into our circuit. It's not actually that difficult. What we need is one of these. This is a Bluetooth connection module. They come in lots of different flavors. This one is a BLE, which is a Bluetooth low energy. And in specific, it is a HM10 variant. The difference of one of these compared to a lot of Bluetooths is this isn't designed to be on all the time. It's just designed to switch on when you need it and turn off when you don't, which is kind of ideal for what we're doing because it's not a power drain. Not that this would really be a concern of a power drain. It has a variety of pegs on it. Going from top to bottom, we have state, which is an output, which you'll basically put a signal out saying whether or not it is switched on. So you could use that to power a LED to say, oh, Bluetooth is on and available. We're actually not going to use that. RxD and TXD are these serial connectors. It's basically data that comes in and data that goes out. So RxD is in, TXD is out. You have ground, which is normal ground, VCC, which is your power, and EN, which is enable, which allows us to send a on-off state signal if we wanted to turn it on and off throughout the power. Again, we're not going to use that, not in this iteration. So we need to wire this in, and I'm going to just do it this way round before I flip it, because I want to flip it so this side is facing forwards, because there's a little LED on this side that shows us when it's on. So I want it installed this way, but the labels are on the back. So we want to have, let's start from the simple ones. So VCC, so we want power and we want ground. So let's take a couple of wires. They're the same color, but it doesn't matter. So on the very right hand side we have power. So I'm going to go into this top track, which has got all of our power, and then pop that here. Then the one next to it is ground. So ground is going to go there. That's going to go into the ground pin on the top track. So those two are now got ground and power. Then we need TXD and RXD, and they go into here. Now, the Arduino does have a TXD and an RXD pin, but we're not going to use them. The kind of serial connections differ. We don't need to go into the specifics of it in this, but it's going to be a lot easier just to throw these into 2 pins. So the next two, we're just going to pop into 2 pins over here. So first one is TXD, and we're going to use pins, let's use pins 5 and 6. So TXD is into 5 and RXD is into 6. Great. So now I'll just line this up with all of those, and they should all be in. So if I plug it in, we just want to watch for the little light coming on, which it does. You can see there it's flashing. So that flashing half-second on-off means on, but not receiving any information, not connected to a device, which is how we're going to leave it for now. In order to talk to the Bluetooth, again, we're going to need another package. So we're going to want to include it up the top here. There are a few different packages, and the way each different Bluetooth type works depends on the package you use and the commands for it. I am using one specifically for a BLE HM10, which is one I had to download. So it's actually named as firmware in here. It is available, so if you just search for BLE HM10 library, you will be able to find this one. I will include links in the description if you want to find it, and I'll using this specific Bluetooth board. But this is the package that we're going to use. And now we'll start to set up a few of the simple things. So it's going to need pins defined. So we just used pins 5 and 6. So we are going to define pin for the Bluetooth RXD as 5. So that's the pin for Bluetooth RXD. And then the Bluetooth TXD is pin 6. So that's the pins set up. Then we want to have an object here which sets up the name of the things that we're going to use to talk to the Bluetooth. Like most of the times when you use an object instantiator, you call it by its name here. Call it by its name. And then we define what we're going to call it. So I want all the connections to the Bluetooth simply to be called BT. Then we just have to tell it what pins we have run on for RXD and TXD, which have just been defined here. So RXD and then TXD. There. So that now means when we do Bluetooth dot something, we can do commands to the Bluetooth for turning it on, receiving information, all that kind of stuff. We'll start just by adding into the setup. We've got all these other setups here, the different begins. Now, Bluetooth is a serial connection. So it operates in a very, very similar way to serial. Much like we've got serial.begin 9600 here. Remember, that's the baud rate. We have Bluetooth.begin 9600 because they run on the same signals. Remember when I was telling you in the last video why we built a state manager to make serial connections shut up from continually doing things? That's why. So this Bluetooth is now running over the same serial connections. So at this point, everything should compile. Let's just check it. Great. There's no point uploading anything to the Bluetooth right now because we need to pause on doing anything with the Bluetooth and actually start writing the mobile app so that we know what information we're sending from the Arduino to the app and what information from the app to the Arduino. I'm going to hazard a guess that most of you have never created a mobile app before. And there are actually, fortunately, tools out there like this one that I like to use, the App Inventor by the MIT Education Department, which makes making an app really easy. Let me show you what I've done, because I've already built the app, because this would take us way too long to do in a video and there's way too many steps to it. But I'm going to take you through the app and show you every piece of it and why it's been done with the way it's been done. And then I'm going to put in the Arduino code to talk to it and take the values in and out. So what this is a pretty simple drag and drop builder where we can come in and take various simple things like a label, stick it onto the page, or a slider. We've got a few sliders here, a switch, all the kind of like typical user interface things you would find on a website or a mobile application. So here we see it visibly, and then we've got a list of the names that I have called things down this right hand side. So we've got a slider here, which is slider red. We've got a few labels here which don't have a name, they're not important. Then these ones here, so label red value, label green value, label blue value. That's because I want to be able to change these and have that number update as I change it. There's a disconnect button you can see, but if we check underneath this list here, there's actually a reconnect button as well, but it is invisible. If I just click the visible down here, there's a reconnect button. Basically, if I've finished with the app, I can just disconnect it. It means that the Arduino stops listening for anything. But then the disconnect button hides and the reconnect button appears. So I just can swap the visibility of those two buttons depending on whether or not it is it's done. And set color. So this is a button. At the moment you can see that it's a dark gray, but as I change the values of these colors, it changes the background color to what the color is going to be. So I have a vague idea. So if I put the red all the way up and the blue all the way up, the background color of this button will be purple. It gives me a vague idea that I'm in the right ballpark when I'm setting the RGB values. Then I can press set color and it will send off the RGB information to the Arduino. There's also a feedback label here which gets information. So it basically says things like the color has been set or we have connected or all that kind of stuff. Just so I've got a little bit of feedback. There's also something hidden which you can't see, which is the Bluetooth LE1. Now, Bluetooth LE1 wasn't a standard thing that is built into this application. It's an extension that you can download and import. If you're ever building this, if you just search for Bluetooth LE1 for the MIT App Inventor, you'll find it on a GitHub, I think. And then you can just download the zip file with the files in that you need, upload to this and use the BLE. But it's just hidden in the background because we don't need to see it to do any changes. So I'm sure the question you're asking is, how on earth do these things connect to the Arduino? Well, that comes with the thing that is really, really clever about App Inventor and the things I like, which is block development, which is up on the top right here. So if we click into blocks, we get all of this. I'm just going to zoom out a bit so you can see. So this is all of the code. Oh, I've just moved something. This is all of the code required to create this application. And we're going to run through it and I'll tell you what everything does and I'll show you roughly how it works. There are default controllers. I don't know what the best thing to call these things is. Building blocks. It's kind of like maths Lego. And we can click on one of these things on the left. So say we want to do something with, we want to set a variable to the sum of two numbers. So we want to say variable A is equal to 6 add 10, right? We take a variable here and we can choose one of the things that a variable can do. So we can initialize a variable, get the value of it, set the value of it, and then initialize things inside other things. There's like loads of stuff we can do just with variables. So we might go initialize the variable a to equal a maths thing. So there's two maths objects there, click them together, and then we said 6 add 10, right? Oh no, that's a logic gate. So we want that there plus something. So then we'd go, we want a number in there, so maths number. So we grab a number, 6, and then you can just, with these blocks, you can copy and paste. Makes life a bit easy. 6 add 10. So now that variable a is equal to 6 add 10. And if later on we wanted to use that, say we were saying, okay, this label, so label 2, which is one of the labels we've got on the main application. Label 2, we can do label 2, set the label 2 text to be that variable. So get global A. This wouldn't actually do anything. This would work. You can see it's self-contained. All the edges do nothing. This one has got these little cutaways. That means they need to be inside something. So it needs to be given a reason to do that. So under what circumstances do we do this? And you'll see here, we've got initializing. So screen 1, when I go back to the designer, this is screen 1. I'm only using one screen, so it's always screen 1. When it initializes, there's some stuff we want to do. And so we could set that label and we put that in there and it will do that when the page initializes. So this is how this thing works. It's a load of drag and drop elements that you put together in building blocks to create things. And it's very, very similar to what we're doing with the Arduino, but it's a lot more visual. It's actually a really good way of learning programming without actually knowing all of the commands specifically. So let me go through what we've done and I'll show you why we've done it. So much like in the Arduino, we've set 3 values to start with. Int red, int green, and int blue. So it's an integer red, integer green, and integer blue. So they're initially set as 0. So the app starts and they're 0, 0, 0. These service IDs and characteristic IDs here are individual for your Bluetooth. When we are connecting to Bluetooth later, you need to be able to know what your UUID and your characteristic UUID is. If you don't know how to get them, let me show you. So in order to find the information that we want from the Bluetooth device, we switch the circuit on, and then we're using this app. It's called BLE Scanner. It's a Google Play app, it's free, and you can see all the various low energy Bluetooth devices that are within the vicinity. Ours is this BT05. So if we connect to it, we're going to get some little bits of information. So some bits of service information that are available here. These are the various services that run on it. The one that we really want is customer service at the bottom, and it has this UUID here, which you can see is the custom characteristic. So this is the characteristic UUID that we want, and above that is the service ID that we want. So those 2 bits of information are the things that we're going to use in our Arduino. And as we can see, those are the IDs for reading and writing and notifying. So they're what we want. Also, if we go back onto the previous page, we can see the MAC addresses of the various devices within range. And this number here, these 12 digits separated into 6 pairs, that is the MAC address for that. So the MAC address is unique for your individual component. It's not going to be shared with anybody else, but these service IDs, if you've got this kind, a HC10, it's going to be probably the same service IDs. With that MAC address, we can just know when we see that Bluetooth connection, connect to it. We don't have to pull up a list of all available connections in the area, choose the one we want to connect to and do it that way. It's going to make our life a lot easier. So we'll make sure we take a note of that MAC address too. Then we've got the RGB value that we're going to send to the Arduino. At the moment it is nothing. and the initial RGB value, which again is nothing. So that's the value that it's going to load up with. It's the combination of strings. We're not going to use that right now. Then initialize a global counter to 0. It's just a number is held in counter of 0. I'll show you why later, but it's basically because I've got a bit of code I want to run only once. So I can change that number and then check if that number is still 0, and if not, don't do it anymore. So when we go into this further code, I've tried to separate it out into sections, so hopefully it'll make a little bit of sense. So when screen 1 initializes, when it loads for the first time, set the feedback label, so this label at the top here, set it to initializing. So we know that the program is coming up because it says initializing. And then the Bluetooth, so the Bluetooth thing here, which is set here, there's loads of different Bluetooth type commands that will do things like read, write, send information, etc. Start scanning. So the app comes up and then it starts scanning for a low energy Bluetooth device. So that starts scanning. When it finds a low energy Bluetooth device, it wants to run this BT connection block, which is here. So it's found some devices and it's going to run this. This is like a void that we did in Arduino. It's just a different way of doing it. So when that device is found, it's going to call the Bluetooth again and connect with address and our plugged in MAC address here. Now, I only am using that in one place, so it doesn't matter to put it there. You could, if you're going to be really anal about doing things properly, say we have a global MAC address here in case we needed to use it somewhere else. Pop that up there and then instead use the get MAC address. So that would be the better way of doing it. So the app initializes, it scans. When it finds a low energy device, it connects to it with that address, with that MAC address. That's us connected to the Bluetooth. We can connect to it. Whether or not any information is then sent back and forth, that's a whole other question. So what do we do then? So then we've got this button at the top, this disconnect button. And like I said, there's a reconnect button as well that is hidden behind it. They just need to be able to do something in case it's scanning and it doesn't find it for some reason, or it finds it and the connection's being spotty. I'll just want to press the disconnect button to kill the signal, and then I can press reconnect and start the signal back up again. So if I click the disconnect button, this one, which is already up on the screen, it will disconnect the Bluetooth device, make that feedback label have the text device disconnected. Then it'll find the disconnect button and make it invisible, so set its visibility to false. And it'll find the reconnect button and to make that visibility to true. So it gets rid of the disconnect button and shows the reconnect button. Then, if we click the reconnect button, it'll run this connection thing again. It'll run this same function, which is why it's in a function, because it gets called from multiple places. And it will reconnect to that MAC address that we know we have. Then, when it's connected, so when it's completed this and it connects with the address, it does a few other things. So it sets the feedback label to device connected, so we know it's connected. Make sure the right button is showing, so it hides the reconnect button and shows the disconnect button. Then it starts to do a couple of like fancy Bluetooth things, and it's going to write a string using these service IDs with the value ready. So what this thing does is going to say which service, it's kind of like which port I'm going to be sending and requesting information from. And it does that using these two IDs, the service ID and the characteristic ID that we were able to get from the BLE information and that we've got stored up here. UTF-16 is just an encoding standard. It's saying, is the string of text that I'm sending in a UTF-16 coding format? It's not for what we're doing, so we just set it to false. And then what string are we sending to the Arduino? Now we're just going to send the word ready. What that'll mean is when the Arduino receives ready, it can go, oh, the app has turned on for the first time. I should send it some values. So in a bit, when we get to the next stage of doing the Arduino, we can get it to listen for the word ready. And when it hears the word ready, it sends the saved values back. So we know we've got them. Which is why when this happens, we then register for strings. What this is saying is we're telling the app we would also like to receive some information. We want to register our interest for receiving stuff. So we do that again, and we set up again those just encoding standards. So that does basically our entire setup when we start the app up. It initializes the things, it looks for the Bluetooth devices, it connects to the right one, it tells it we're ready, and then it just waits. So that's what we do when we set up. Outside of that, there are the things that we can do when the sliders change. So I've got these three sliders, red, green, and blue, and their values here. One of the cool bits is this little button at the bottom. As we change these sliders, the background color will change to the value that is being created. So we've got three simple little functions here. So slider red, when the position changes. So we do that by looking at the actual individual component here. When we click on slider red, it has a few things, so we can get like its visibility or its width or its height. But this one is an action that's done when something is interacted with it. So when the positions change, so when you slide on it, we're going to set that init red, that initial red value here is going to get set to the thumb position, so where the what number it is, but a rounded number. So this value, slider thumb position, is what's called a floating number. It's like you could move it up between 0 and 255, but you go to 65.8 or 22.9. You know, it's a point something. It's a decimal number, a float, as they're called in the programming world. So we do a round, which will just round it down to the nearest integer value. So we get like nice whole numbers, just makes life a lot easier. Plus the NeoPixel doesn't understand non-integer values. Then the label text is also that rounded number of get global int. We actually don't need that round there, I've just realized, because we've already rounded that number. So we can get rid of that. Oh no. So, because otherwise we're rounding an already rounded number, and it's just not necessary. So we do the same with those. Yeah. So we set the value of that variable to the rounded number, and then that variable sets the text at the end. So as we slide this, that number represents what number we're sliding on, and then we update the button color. We'll come to that in a second. So the same happens there on the red, the green, and the blue. They basically update the corresponding value. They based on the position. They update the label based on the variable, and they update the button color. So what this does is run a function and set color. So set color is the name of this button here, set color. So it's saying set its background color to, and then we make a color using this colors block here. So it's got a few things where you can make a color, and you make a color with a list and give it an RGB. So we make a color with the list and we give it the red, green, and blue that we've just set up above. So as we change these things, that background color will change based on these updating values. Then, when we click that button that says set color, we run the Bluetooth send command. So this thing goes and creates this new variable, so send red, green, blue, that we defined at the top, send red, green, blue. We're going to create a new value to send. And what that's going to do is just join the red, the green, and the blue with a comma in between them. So we join red and comma, we join green and comma, then we join those two things together, and then we join those two joined things with the blue. It's a little bit arduous how you have to do joins in this, but it does does work. It does make sense. So this will leave us with a string like 255, 65, 91. Then we're going to call the Bluetooth again, put in the service IDs just like we did before, and send it that string. So we're going to send it a color in comma separated format. And we're going to set the feedback label at the top to color sent and that color. So there is one more thing that we want to do, and it's over here, and it's listen for strings received. So it's information coming to the mobile application from the Arduino. Now, like I said before, there's some things that we want to run only once. This is that one thing. And that's why we have a initialized global counter at the top, which is 0. So as the app boots up for the first time, we're going to say, is the global counter equal to 0? Which it will be because we've initialized it as 0. Then it will do all this stuff. Then what it's going to do at the very end of this stuff is change that counter, global counter, to 1. So from then on, any more strings that it receives, it's just going to ignore. What this does is mean that we can look when the app opens for the first time and set the initial red, green, and blue values that are sent to the app from the Arduino, and we can set them, but then we don't want it to come in and take over because we might be, updating our values and then suddenly it disconnects and reconnects and then it resends the values to us from the Arduino and just messes with what we're doing. So we just have it so it just runs that once. And what this does is read strings. So when it is looking for strings that receive, then it's going to read those strings and look at getting the string values here. So strings received here, we can access get strings values. So it looks at the string that's being sent, and one of the quirks of the way data is sent from an Arduino is does it as array values. So the entire string is inside square brackets with double quotation marks at each end. So what we're just going to do is replace the text of that string value, and then we replace the segment of a left side bracket with a double quotes with nothing, and then a right side bracket with double quotes and nothing. So basically that just removes those things from the string and just leaves us with the 3 numbers, which are a comma separated list, exactly the same as we are sending to it. So we've got a red, comma, green, comma, blue. So then what we're going to do is set the red value and this select list item list index 1, all weird block typings. So what we're really doing is we've worked from the right to the left is we get that initial RGB value, which we've just set here. So it's the red, comma, green, comma, blue. And we're going to split it at the comma. So then it is in 3 pieces. Then it's technically an array, which this block builder considers lists. So these are all the things that are done with lists. So individual items that are all related to one another. So we're going to select the item from this list in index 1. A little bit confusing here is usually in arrays, they index at 0. So your first element would be 0, your second one would be 1, your third one would be 2. That's why we've done 0, 1, 2 in the Arduino app. Here it indexes the first one at 1. So 1, 2, 3. Don't know why. That's how it's done. So red is when we split it, the first value is red, the second value is green, the third value is blue. So we've just updated those variables, red, green, blue. Then we come in and set the slider position. So set the slider's thumb position to that red value. So the green one to the green value, blue one to the blue value, and then set that, like I say, the global counter to 1, so this never happens again. And that is the entire code and setup. So the design here is everything for the app. Not actually all that difficult. I will do a couple of screenshots of this page, this block setup, and I will stick them in the comments. There'll be a bunch of stuff you can download for this lesson, and some screenshots of this will be in there, so you can copy this setup if you wanted to do that. If you wanted to test this application, you use it with a AI companion. There is a mobile app that you can get. It's called MIT AI Companion app. You'll click on this button. It'll give you a code like this, which you scan with your phone through the MIT Companion app. And then this app will just run on your phone exactly as it will when you're finished. I've got to the point where this app is complete. So when you've done, you can build an Android app like this, which I just then, like I say, throw on a Google Drive, downloaded from a Google Drive to my phone, opened it, and now I have an app installed which does all of this with all of these blocks and everything stored in the background. So time to add our last bit of code into the Arduino for this entire project. It is the case of listening for when the Bluetooth is activated, when it is, seeing if there's signals coming in, what they are, and then how to respond to them accordingly. We're probably going to want to create strings and be able to send them off. So it's just a good idea that we define them initially. So we're going to create a string type. You have to be careful using string types in Arduino. They can get a little bit runaway. Really, this would probably be better being done as 3 individual elements that are stored individually and then sent as an array. But we're going to do it this way just for the sake of simplicity. So we're going to do a string, which is my Bluetooth command. And we're going to start by setting it to nothing. So that means all the way through the application, we can access this Bluetooth command string and share it around. So we've already initialized our Bluetooth. So our Bluetooth is up and running, and we do that in the setup. So we'll do just a note here, initialize Bluetooth. So we're going to want to do something in the loop. After we've set these digital states, we're going to want to see if the Bluetooth is available, and this is just another command that comes pre-packaged into the Bluetooth package, this BLE HM10 package. So Bluetooth.available. So if it's available, we're going to do something else, and we're going to not do any of this basically. So we're going to set settings, and that can be our settable function. So let's put another void down here, and we'll do void set settings. And this is only applies when a color is being set. So we're going to go through this in a short amount of time with the serial up. So tools, serial monitor. Where's my serial monitor gone? There it is. So serial.println settings being set. So this is just so that we can keep track in here of what's going on. And we know that Bluetooth has become available, which means something's about to be sent to us. So we want to start listening for whatever is being sent. And we can do that by, that string we just created, Bluetooth command. We're going to set that to whatever has been sent in by the application. So we're going to do Bluetooth.read string until, and then use a special character, which is a \n. So read string until \n. \n is a new line. So when you send a bunch of information one after the other, at the end of each one, it's actually got a new line that says a new thing is happening. So it just basically reads that one string and not a whole load of stuff. So that Bluetooth command is going to be set to whatever has been sent in. So we can just print another line of saying the raw data is equal to that plus BT command. So that would give us a line of showing what the raw data being sent from the application is. So if you remember, there are two things that we need to look for. If we've been sent ready as a word, or if we've been sent a color. So what we're going to do is check if the thing that we've been sent is the word ready. So if Bluetooth command is equal to ready. So in here, we're going to do the initial request for color. And if it's not ready, that means it's the only other thing that we are sending, which means it's setting a new color. Let's take the easiest one, which is to create the string, the RGB string that we're going to send back to the app. And we can just do it by, we'll create a new string and we'll call it saved red, green, blue, and initialize it as nothing. Just as an FYI, sometimes when certain functions inside Arduino are trying to set things to strings that were originally like a character, especially when something is pointed, I'm not going to get into that now, it doesn't like it. So it's sometimes, if we were to try and initialize this string as a value, so like reading the value from the memory like this, it will go, well, this thing is an integer, so I don't want to initialize a string as an integer value. But if we, for some reason, initialize it as nothing, then reset it as saved red, green, blue is equal to that. So now that saved RGB is equal to that. It's fine with that. Don't know why the difference is, but there you go. Then we can use a thing called a concat. Just, it keeps things nice and readable. So red, green, blue is equal to, dot concat, like I said. So that's concatenate. Concatenate strings is where you join lots of strings together. So we're going to concatenate it with a single byte comma. We're actually going to do that twice, but there are going to be 4 concats in all. So we're going to put the read value 0 in here, so this is taking that value out of the memory, spot 1, and then we need to do concat with memory spot 1 and memory spot 2. So this has created a blank string, and then it's made it red value, comma, green value, comma, blue value. So it's made a string which has got all those things in it. So we can just do a serial.println and string to send plus saved RGB. And then the way we send it to the Bluetooth is exactly as simple as we send it to the serial monitor, and it's Bluetooth.print. And we're going to do Bluetooth.print saved RGB. That's it. That's how we do the initialization. So just to recap, if the command is ready, so the ready command comes from the application, we create a string based on the values that we've got stored in the memory, and we send those back as a string to the Bluetooth, not BR. Otherwise, if the thing that we have received is not ready, it must be a color. So it'll be coming in the same format, red, green, blue. Stupidly, splitting strings in Arduino is a pain because like I said, it's one of those programming languages that is pointed. We're not going to go into that now. But what it means is when you try to have a string and split it by a certain value, in other languages, for example, JavaScript, you could take a string, do a split by a comma, and it would create an array, which is like a holder of various different values. Then you could access each one of those individually. You can't do that in here. It doesn't allow you to do it natively. There are application plugins, though, that will add that functionality just to make life a little bit easier. And this is one little use of it that we need to do. So it makes sense to use the plugin. And the plugin is one called String Splitter. So if we go to include library String Splitter. So this is one I downloaded. You can find it if you search for Arduino String Splitter. Very, very useful for what we're about to do. So if string that has come in is not ready, it's obviously setting a new color. What we need to do is see what is the value that has been sent, split it into the three sections, and then allocate those three things to the memory values, and then update everything. So we're going to start using String Splitter. And the way it works, the documentation that it comes with is pretty good. We will do String Splitter. We need to define a variable, which is actually a pointed variable. So RGB, and you have an asterisk at the start here. Then we're going to do that is equal to a new String Splitter. So much like how we use the objects above, this is very, very similar. And the string we're going to split is Bluetooth command, which is this function that we are testing here. So we're going to split Bluetooth command based on the character of a single comma. And how many splits are there going to be maximum? 3. So what that has done is created a new value called sent RGB, which is split. So it's really an array. We can access it as an array, which means I can now do some new values. So we're going to have an integer of our sent red. So the red that we've got sent is sent RGB, which we've just defined above, and then a bit of code that comes from String Splitter, which is get item at index, and then the position. So now this string has been split down into multiple parts, and it's got 3 positions, 0, 1, and 2, where the values are that's been split. I'm just going to want to quadruple check that the thing that is being sent and stored here into this integer is actually an integer, because there's a good chance that this is a string, and we don't want to save it as a string, we want to save it as an integer. So we're just going to do a toInt, which will take whatever we've got there, and if it is a number, even if it's a string format, it will convert it into an integer. So we need to have 3 instances of that. So red, green, and blue are there, 1 and 2. So now I have these 3 values that have got the red, the green, and the blue that I've been sent from my mobile app. I need to just quickly test them, very much like we did at the top here, to make sure that they're within the right limits. So we're going to basically copy this, paste it in here, and then change these values. So sent. So we're checking, is it a number, and is it between the acceptable ranges? Because that's the only thing that we want to be storing into our memory. And if it is, we can do the EEPROM and write. So we're going to write. Like I said, one of the big concerns is these can only be written to 100,000 times, even though that is a lot of times. So by keeping it in this one function and having it only run kind of like outside the loop, when things are available, it stops it just firing off all the time. So we're going to write to position 0, and we're going to write the value of sent red. We'll do that 3 times again. 1, 2, G, and B. So if the values are all correct, all 3 values have come in, there's no garbage text in there, there's nothing that's given us issues, write the new values to the memory. Almost there. One last thing to do. The one last thing to do is the glow here. So at the moment, when we are lighting up the glow, we are just doing purple. So we need to change this so that the glow light updates based on the values that are stored in our memory. But I don't want to use maximum brightness at any time. And using the sliders, they slide all the way up to 255. So if I put it all the way up maximum red and then set it, it would set it at maximum red. I don't want that. I want whatever value I choose to be muted a bit. So it's not going to be the exact color that we pick on the sliders, but it's going to be pretty close. So we want to make a muted version of each one of those colors values. How we're going to do that is just do a little bit of maths based on the normal brightness. So we're going to set new values in here. So we've got an integer for the brightness adjusted red, which is going to be our normal brightness times by the value stored in the memory, so EEPROM.read 0, divided by the maximum value, which is 255. So what this will do is we'll find the ratio of our number compared to the max number, and then adjust it by our normal brightness. So instead of being kind of 255, if we sent it 255, it'd be 10. So basically it's going to just dim everything right down. So brightness red, brightness green, brightness blue. And these are all adjusted just by the normal brightness. This is, again, why I said we needed to find that normal brightness earlier, because it just controls everything. And then instead of setting these as these 3 values, we set them as the 3 brightness values. So brightness red, brightness green, brightness blue. That, my friends, is everything. It is done. So as long as this all compiles, which it does, this should be ready to go. So what we need to do here is hook up. Yep. All my code is now on here. But in order to show you this app working fully, I need to just switch my cameras around, because right now I'm recording the circuit board on my phone, and my phone is where the app is. So let's just switch things about. So let's take a little look at our final circuit and what we've got. We plug it in, we'll see it fires up into the daylight running mode, and then our buttons do what our buttons have been doing all this time. So this one is the reverse light. You can see it's white-ish. It's a cool white. This one is the full brightness. And then this one is whatever is currently saved into our underglow, which is purple. So there's a kind of purple color saved in there. I said I'd been playing around with the Arduino previously, so it's just leftover code from that. But as we can also see, we've got a little flashing red light here on the bottom of the Bluetooth. That means that this thing is on and running, but it's not connected to anything. So let's play with it with the app. Here's my phone, and there's my dog. And actually, if I just start by opening this LED lamp, this is the application that comes with GlowKit. So you would set your GlowKit using this, it's just scanning for it, but it won't find it. And as I change the wheel color, you can see the R, G, and B values at the bottom there changing. So when I set it, say, purple, or whatever color I set it to, it will give me the RGB values. So this is what I'm going to be using in my app. So my app, I put next to it here, and it's called Spoiler Alert. So it connects, we should see that light go full red, and it's connected, device connected, and as you can see, the color has come up purple because of the code we put in there. So it sent that ready request, it sent back the color that it's already done, and these are the values that purple is currently set to. So let's change it to something different. We don't want that purple, we want to have it full green. So let's add the green up, bring these two values down, green up, set. And you can see it's sent 02550, so it's sent green, which means if we press the button now, it is green. So that color matches, and we can do that with anything. So we could do yellow. Yellow will probably be a bit off yellow, but yeah, like a greeny yellow, or we could go white if we wanted. Or we could take the red out and go for a really light blue. Or we can mess around, find the color we want. What do we want? We want, I don't know, there's so many options. An orange. So there, like an orange. Yeah. And then we can keep playing with this until we're happy. Then that's the value we're going to have. We're going to set green underglow. So we can just disconnect. That's it. That's the end of quite a big and technologically intense little video. I genuinely hope, though, that somebody has seen this, maybe it's you, and gone, oh my God, I can actually create something really cool using this combination of technologies. And like, the key is to take away the process that we go through. So like, how we sent that word ready, you could send 10 different things and have 10 different things happen in the code based on the keys that you sent it, rather than trying to send it something dynamic. So you could create an app that controls various forms of disco lighting inside your car, or you might have I don't know, a GTR with circle headlights on the back, and you've got different animations that you can then set off. I don't know what it is. There's endless possibilities, and if you do come up with something really cool, I would absolutely love for you to send it to me. Either stick it in the comments or hit me up on Instagram, /Valentine Autos on there, exactly the same as we are on here, because I would really love to see it and see what you come up with. Obviously, if you have any questions about this process, please do just ask, and I'll see what I can do to answer. I'm not going to know everything to do with Arduino programming, but I do know quite a lot. I was a programmer for 25 years. Otherwise, we do have part 3 of this video coming out probably next week, where we're going to put all the components back in that are required to wire this all up to the car, as well as building custom 3D printed enclosures, putting all the components into proper little like circuit things in the breadboard, creating custom harnesses so we can clip everything in and out and store it away safely in the car, so it's not going to rattle around and potentially cause any damage. But we do have part 3 of that coming. I did want to do it in multiple parts, because otherwise it'd be like a 4-hour long video, and none of you is going to watch this. It was hard to record, I'll be honest. Anyway, if you do enjoy this kind of content, please give us a subscribe. We're trying to do a lot more of this, and it really helps us get to the points that we would like to be at the future. And otherwise, we will see you all in the next video. We've got lots and lots of cool stuff coming. In fact, I'm wrapping my car, hopefully to completion of, you know what I mean, this week. No. Make sure you give us a like and subscribe. It really means a lot to us, and I will see you in the next one. Whatever you do with the rest of the day, have a wicked one, and I will see you in the next video. Take it easy, peeps. Bye-bye.